So just as a reminder, the reason we're able to calculate the pooled variance is because we're assuming that the population variances for both offices are the same. We don't know what they are, they're unknown, but we're assuming that whatever they are, they're the same value. And that's an important assumption when we're calculating the pooled variance. The formula for the pooled variance is the pooled variance S squared sub p equals the number of observations in sample x, nx, minus 1 times the variance of sample x, which is S squared sub x, plus the number of observations in sample y, ny, minus 1 times the variance in sample y, S squared y, divided by nx plus ny minus 2. So based on the given table that's provided in the question, we can find these values. Ns, the number of observations in the sample for small offices, is 46. The variance for the small offices, well, we're not given the variance in the question, we're given the standard deviation. So it's important to understand when calculating the pooled variance, we need to have the variance of each sample, not the standard deviation. So the variance of the small office sizes is 0.545 squared, because again, that 0.545, which is given in the question, is the standard deviation. We go on for the medium-sized offices, and the number in the medium-sized sample is 52. And the variance for the medium-sized offices is 0.533, which is a standard deviation, which is given, squared. Because again, the variance is a standard deviation squared. So plugging in these values, we can calculate the pooled variance. We have all the values we need, and we just need to plug them into the equation. We see it's 46, the number in the small sample, minus 1, times the variance for the small sample, again the 0.545 squared, plus the number in the medium sample, 52, minus 1, times the variance of the medium sample, 0.533 squared, divided by the sum of the observations in the small, which is 46, in the medium, which is 52, minus 2. And we see that the pooled variance is 0.29015.